All right, welcome once again to another episode. In this one, we'll be talking about breadth first search algorithm. So, in the last one, we talked about depth first search algorithm. That was interesting one. That it discovers every single branch to the end of it, and then it takes another branch. But breadth first search is a better way to approach the problems. So, how does this actually work? So, breadth first search. I just fumble a little bit at it. So, breadth first search algorithm is basically a traversal algorithm that explores the graph by level. Unlike DFS, which goes as deep as possible, each branches before backtracking, BFS explore all the neighbors of the node before moving on to the next method. This method ensures that the shortest path in terms of number of edges is found in an unweighted graph. So what this basically does is it explores all of the possible branches in a single run. So let's just say that I have a particular branch of A. I have A and it has two childs, and then A have some childs and B have some childs, right? So if you're using depth first search algorithm, it will basically start from A, then it will go to B and explore the B's left child, and then explore the B's right child, and then come back and then go to C, right? But breadth first search algorithm is pretty much different. It will explore B and C at the same time. First B, then C, then B's left child, and then C's left child, and then B's right child and C's right child. That's how it works. Breadth first search algorithms basically discovers all of the possible branches first beforehand and then find the smallest way that can help you reach your goal state. And that is what it takes to reach the goal state as fast as possible. Alright, so the steps of performing a breadth first search algorithm is start at the root or any arbitrary node, mark the node as visited and add it to the queue. Then the third step is while the queue is not empty, dequeue a node from the front and then visit all the unvisited neighbor, mark them as visited and enqueue them. Repeat this process until all nodes are visited. Same as our all right, so it's done up here. So let's just do the practical stuff. Let's get our hands on practical so that you can understand it more better. All right, it's not rocket science. It's too damn easy to perform depth first search algorithms and breadth first search algorithms. They are really easy. So the first thing is you have to import a library called collections and perform collections DQ. So the first thing you do is create a function BFS, breadth first search algorithm. You have two arguments, graph and a start point from where you have to start, and then you visit the branches as you go forward. So visited will be a set, an empty set, and then DQ is Q is equal to DQ, the start. Then it's a simple stuff. So while Q, so I'm going to explain you as we go forward. So the first thing that you have to do is mark a node as visited and EQ all of them, right? As you go forward, you have to EQ all of the nodes that you're visiting. And once you're done with that, all you do is just create a while loop to check if queue is not empty. Till the queue is not empty, not if queue is not empty, till the queue is not empty, current equals to DQ from queue. And how do you do that? In coding, we say node is equal to q.pop left. You just pop the left element. And then for each neighbor in current neighbors, okay, let me just done with the coding up here. Print the node and then pop the stuff out. Just say visited. Just tell it that okay, this particular piece of code is visited, or let's just say this particular piece of node is visited. Not piece of node, it's actually the node. So for each neighbor in current neighbor, like A's neighbor is B and B's neighbor is C and so on and so forth. So if neighbor is not visited, mark it as visited and enqueue the neighbor. So you just enqueue all of them into a set, and whatever the sequence of the set is, that is actually our BFS algorithm, breadth first search algorithm. And that is the path of breadth first search algorithm. That this is how the breadth first search algorithm performs. This is how it searches through things. So we're gonna just copy the entire what that exactly is called, that agency list or whatever that happens to be. All right, so we're just going to say print. Inside of the print we're going to say breadth for search. Simple as that. You don't necessarily have to say that, but I'm just saying it for fun, just for fun. All right, so bfs, and now we're going to call the function bfs. Inside of that we're going to pass two arguments. Bfs, the first argument is going to be the adjacency list, which is going to be graph, and then the starting point, which is a. And once you're done with that, you'll be able to see an output. An output is going to be very, very perfect. A, B, C, D, E, F. Like see, A, B, C, D, E, F. That's how it works. You can just create a visualization on the piece of paper and can see how this works. So once again, thanks for watching, and if you like the video, then hit a like button. If you dislike the video, then don't hit the like button and just simply hit the dislike button. And subscribe for watching. Subscribe for more content like this. Till then, keep watching. Code with